Welcome. So I have a whole little playlist on how to convert from standard form to vertex form, but I figured I'd just do one little video just so you have an idea in case you come across some problems where you have to be able to solve or graph. You have to be able to convert from standard form to vertex form. So I figured I'd make a nice little video for you to do this. So what we're planning on doing is going from y equals ax squared plus bx plus c and converting that to y equals a times x minus h squared plus k. And there's a lot of reasons why we want to go through from standard form to vertex form. A lot of times it's easier to graph, it's very easy to find the vertex and so forth. However, it's not always so simple to convert from one to the other. So what I did is I'm going to do 3 examples for you. Now the main important thing when we look at standard form now to vertex form is we notice that vertex form has a binomial squared. And when we take a binomial and we square it, what we get is what we call a perfect square trinomial. All right, and that's what we're going to do is we are going to create what we call a perfect square trinomial. And we're going to do that by what we call the process of completing the square. So there's going to be a couple steps, and I'm just going to kind of go through each one individually. And I'm actually going to do it for each problem all together. Now, the first step, though, we need to do is we need to make sure that when we are creating a perfect square trinomial, that we have a is equal to 1. So here, you can see we have a equal to 1. So we're all set. Over here, though, I have a negative, right? That's a negative 1. So what I'm going to have to do is factor that out. Now, when I'm completing the square, I only like to factor it out of the first 2 terms. So I have y equals a negative 1 times x squared minus 6x plus 11. All right, now I'll talk about, again, completing my perfect square and what we're going to do. But as long as my a now is equal to 1, I'm all set. Over here, I have to factor out a 5. So I'll factor out a 5. So I have y equals 5 times x squared plus 2x plus 1. Now again, I'm only factoring out of these first 2 terms because I'm going to show you what we're going to do is I'm going to now create, all right? And what we're going to do is we're going to look at only my quadratic and my linear term. So right now, those are a binomial. And what I'm going to do is I'm going to take those terms and make them into a perfect square trinomial. And I'll show you how. So to do that, what we're going to do is we're going to take b divided by 2 and then square it. So in this case, my b, if we had ax squared plus bx plus c, b is my coefficient of my linear term. So that's going to be 4 divided by 2 squared. Well, 4 divided by 2 is 2. 2 squared is equal to 4. Here, my b divided by 2 is going to be negative 6 divided by 2 squared. Well, negative 6 divided by 2 is negative 3. Negative 3 squared equals 9. Here, I'm going to take 2 divided by 2 and then square it, and that equals 1. So now what I'm going to do is that is my value that completes my perfect square. So what I'm going to do with each one of those values is I'm now going to add it to my other 2 terms. And what that's going to do is that's going to now create a perfect square trinomial. So let's go ahead and write that out now. So when I add that in there, so I have x squared plus 4x plus 4. Now what I have done is I have created a perfect square trinomial, and then I'll just have minus 5. Now I'll come back and I'll explain something in a second. So here I'm going to add 9 now inside the parentheses. So I'll have y equals negative x squared minus 6x plus 9 plus 9 plus 11. And then over here, I'll add 1 inside the parentheses. So I'll have y equals 5 times x squared plus 2x plus 1 plus 1. OK, so notice how everything else is staying the same. The only thing I did is I took my middle value, divided by 2, squared it, and then added it to my quadratic and my linear term to create a perfect square trinomial. Right? OK, now adding this number is great, but you got to look at this, and we have an equation going on. When we have an equation, you just can't add numbers to one side of the equation without adding them to the other side of the equation, right? If I have an equation, if I add 1 to the left side, I have to make sure I add 1 to the right side. So that was a proper about using our properties of equality. So right now you can see all to the right side, I'm adding a value. Now, When solving, a lot of times what we like to do is we like to add it to the other side as well, because that's going to be your equality. However, when I'm trying to convert it from one form to the next, I'm still solving each value for y. So rather than adding the same value to both sides, what I'm going to do is I'm going to add the 4 to the right side, but then I'll just simply subtract it on that side as well. The difference being is one value I added inside the parentheses, and the other value I'm adding outside the parentheses. Well, that's very important because when I add 9 inside the parentheses, you notice that this 9 is being multiplied by -1. So when I subtract the 9 outside the parentheses, I have to make sure I also multiply that by a -1. Over here, when I add this 1, so now I'm going to subtract 1, notice that the 1 inside the parentheses is being multiplied by 5. So I need to multiply this 1 by 5 as well. All right. So why are we working with the perfect square trinomial? Why do we want this trinomial? Or what is a perfect square trinomial? A perfect square trinomial is when we have the exact same values multiplied to give us our c value, but then add up to give us our b value. So what all these perfect square trinomials can be factored into are binomial squareds. So now I just simply need to say, all right, what two numbers that are exactly the same multiply to give me 4, and then add to give me 4? And we can say that my final value is going to be y equals x plus 2 squared. And then I can just combine minus -5 minus 4 is a -9. Now I have taken this equation from standard form all the way into my vertex form. Here, when I write this, I have y equals negative. I don't really need to write the 1. So now I see what two numbers that are exactly the same multiply to give me 9 and add to give me -6. Well, that's going to be x minus 3 squared. Notice how I'm always getting this binomial squared. Then I look at this. I say -1 times -9 is +9. +9 plus 11 is 20. And there you go. Now my equation is in vertex form. Over here, I say what two numbers are that are exactly the same, right? Because a perfect square trinomial always gives you a binomial squared. What two numbers that are exactly the same give me 1, multiply to give me 1, and add to give me 2? Well, that's going to be x plus 1 and x plus 1. So I say y equals 5 times x plus 1 squared. And then 5 times -5, or 5 times -1 is -5, plus 4 is -4. Or plus 1 is -4. So there you go, ladies and gentlemen. That is how you convert between standard form and vertex form. Thanks.